welcome back. Today we're in 9.1. It's a continuation of what we did yesterday with the patterns and sequences. So a sequence is an ordered set of numbers. You'll just see a set of numbers separated by a comma. Each number in the sequence is a term of the sequence. You'll see that in a minute here. A sequence that goes on forever is called an infinite sequence. So that'll be represented by 3 dots. And then a finite sequence has a limited number of terms, so it does not continue on forever. So you'll see it close out with the brackets. You won't see any triple dots or whatever those are called. Ellipses. You won't see any of those. All right, so think of a sequence as a function, right? And a function is like an equation that we just keep inserting x's into. And the domain gives the position. So if you look at sequence 1 here, it says 3, 6, 9, 12, 15. The domain would be like the term numbers. So term number 1 is 3, term number 2 is 6, term 3 is 9, term 4 is 12, term 5 is 15. So those are like our domains or our inputs, the term number. And then the range is kind of like your output. Like when you have the first term, the output is 3. When you have the second term, your output is 6. So those are like your range values. So if you look, sequence 1, you don't see the dot, dot, dot. That is a finite sequence. Sequence 2 has the ellipses. So that means that sequence goes on forever, meaning it's an infinite sequence. So let's try some of these out. If I can go to the next slide. There we go. Writing terms of a sequence, write the first 6 terms of a sequence. Now when you see a sub n, that's just like your term number. So if we're doing the first 6 terms, we would say a sub 1, and that would represent the first term, meaning we're going to substitute in 1 for n. So 2 times 1 is 2, plus 3, 2 plus 3 is 5. Then let's keep going. We'll find the second term, meaning we're going to substitute in 2 for n. 2 times 2 is 4, plus 3 is 7. Now you'll be able to see a pattern here usually, but we're going to write it all out. A sub 3, 2 times 3 plus 3, 2 times 3 is 6, plus 3 is 9. The fourth term would be 2 times 4 plus 3. 2 times 4 is 8, plus 3 is 11. I'm going to scoot down these other problems. As if we were writing over them, that would be a problem. Alright, a sub 5, 2 times 5 plus 3, 2 times 5 is 10, plus 3 is 13. I am going to move myself. And the sixth term, a sub 6 is 2 times 6 plus 3. 2 times 6 is 12, plus 3 is 15. So again, you could have recognized the pattern that they were going up by 2 each time, which is derived from that part. No big deal. But it's not always going to be the case. So we are going to find the first 6 terms of this sequence. F of n equals negative 2 to the n minus 1 power. So f of 1, right, this is function notation, is negative 2 to the 1 minus 1 power. Right? We're substituting these in for n. So 1 minus 1 is 0. Anything to the 0 power is equal to 1. So then let's try 2. Negative 2 to the 2 minus 1 power. Now, 2 minus 1 is 1, and negative 2 to the first power would equal negative 2. Then we do f of 3, negative 2 to 3 minus 1. 3 minus 1 is 2, so we have negative 2 to the second power, which will give us positive 4. I'm going to have to start the next video. I see I'm running out of time. I just talk too much.